For the calculation, firstly we need to divide the strip to 3 strips. Then we will need to find the value of A, which is B times L. We will get 223.563 meters squared. And we will need to find value of Lx and Ly. Lx, we will get 6,205.024 meter to the power of 4. For Ly, we will get 2,795.696 meter to the power of 4. For the value of Q, we will get 13,300 kilonewton. For the value of X, we will get 6.351 meter, and EX, we will get 0.226 meter. And Y, we will get 3,000 kilonewton meter on the right from center. For the value of Y, we will get 8.719 meter, and the value of EY, negative 0.406 meter. The value of MX, we will get negative 5,400 kilonewton meter on the bottom from center. Therefore, at A1, QA1, we will get 58.123 kilonewton per meter square. At A2, QA2, we will get 51.55 kilonewton per meter square. At A3, QA3, we will get 44.977 kilonewton per meter square. At B1, QB1, we will get 63.475 kilonewton per meter square. At B2, QB2, we will get 56.902 kilonewton per meter square. At B3, QB3, we will get 50.33 kilonewton per meter square. At C1, QC1, we will get 68.653 kilonewton per meter square. At C2, QC2, we will get 62.086 kilonewton per meter square. At C3, QC3, we will get 55.508 kilonewton per meter square. At D1, QD1, we will calculate and get 74.005 kilonewton per meter square. At D2, QD2, we will get 67.432 kilonewton per meter square. At D3, QD3, we will get 60.86 kilonewton per meter square. The determination of shear and moment diagram for strip 1. Firstly, B1 is 3.125. The average soil pressure will get 66.064 kilonewton per meter square. The total soil reaction will be 3,767.701 kilonewton. The average load will get 3,634.213 kilonewton. So modified average soil pressure will get 63.723 kilonewton per meter square. The column load can be modified in similar manner by multiplying factor F1 1.03 at the factored column load QA1 550 kilonewton, F1 571.091 kilonewton, QB1 1200 kilonewton, F1 1246.016 kilonewton. For QC1 1200 kilonewton, F1 is 1246.016 kilonewton. QD1 is 550 kilonewton and F1 is 571.091 kilonewton. Based on the shear diagram, the value that we will get is 24.89, 546.11, 653.65, 592.35, 592.35, 653.65, 546.11, 24.99. And from the moment diagram, the value below we will get is 74.16, 555.31, 747.16. The value above is 1.56, 325.81, 325.81, and 1.6.
Okay, as for the strip 2, the B2 is 6 meter. Then we use the average soil pressure QAV2 and we found 59.491 kilonewton per meter square. And the total reaction is QAV square, QAV2 times B2 times length. Then we got 6514.286 kilonewton. Then we find the average load by dividing it by 2. Once we got the average load, we use the QAV modified. Then we got 56.223 kilonewton per meter square. And then we divide it by 5,800. We got F2 1.062. So the factor column load is given here. First, QA2 is 636.97 kilonewton, and then QB2 is 2123.16 kilonewton. QC2 is 2123.16 kilonewton, and then QD2 is 1273.992 kilonewton. So this is the point load C2, point load D2. And this is the shear and bending moment diagram. So the maximum shear is 1437.88 kilonewton. And this is the bending moment. So the max bending moment is at FD2, which is 5737.45 kilonewton meter. As for the strip 3, our B3 is 3.125 meter. Then as usual, we use average soil pressure formula to find the average soil pressure. We got 52.919 kilonewton per meter square. For the total soil reaction, we use QAV3 multiplied by B3 times length. Then we got 3018.013 kilonewton. Then we find the average load by dividing it by 2. Then we got QAV3 modified by dividing it by B3 times length. So we got 61.521 kilonewton per meter square. Then our F3 is 0.877. Our factor column load is QA3 equal to 5,500 kilonewton. F2 is equal to 530.79 kilonewton. QB3 is 15,000 kilonewton. F2 is 15,092.365 kilonewton. QC3 is 15,000 kilonewton. F2 is 15,092.365 kilonewton. And for QD3, 500 kilonewton. F2 is 530.788 kilonewton. So here is the point load: 531, 1592, 1592, 531. So here is the shear and bending moment diagram. The maximum shear is 940.66, and the maximum bending moment is 666.94. Determination of thickness of the mat. For this problem, the critical section. So U is equal to 2000 kilonewton, which is equal to 2 meganewton. And then we find B0 is equal to 0 bracket 0.4 plus D, where we will get 4.0 multiplied D plus 1.6. So our F prime C is 20.7 meganewton per meter square. Lambda is equal to 1, beta is equal to 1, alpha at is equal to 30. Then we use this formula. Then we find D1 is equal to 0.3097 meter. Again, D2 is equal to 0.332 meter. And then we find D3 0.408 meter. So D max from all of this is 0.408 meter. Therefore, the thickness, mat thickness, is equal to D 0.408 meter. Now hash is equal to 0.408 meter plus 0.076 meter plus 0.025 meter over 2, which we get 0.497 meter. So the thickness of this mat will satisfy the wide beam shear condition across the 3 strips under consideration.
Next, the determination of reinforcement. From the moment diagram shown above, it can be seen that the maximum positive moment is located in strip 2. Thus, the magnitude along the span of strip 2 is 956.2 kilonewton. Similarly, the maximum negative moment is located in strip 3 and its magnitude across the strip 3 span is 308.1 kilonewton. By using the positive moment, we will find the area of reinforcement to determine the minimum area of size of bar to be used in the for the reinforcement. So using the formula of AS, the minimum value of area of reinforcement is 6,035 millimeter square per meter. So the size that we will be choosing will be 25 millimeter diameters bar at 75 meter center to center. The area of reinforcement for 25 millimeter bar is 6,545 millimeter square per meter, which is enough to sustain the moment that was calculated. Similarly, for the negative moment, reinforcement is also needed on strip 3. By using the same formula as previously, the minimum area of reinforcement required is 1,738.25 millimeter square per meter. We will be using the same size with different spacing, which is 250 millimeter. The chosen area of reinforcement will be 1,963 millimeter square per meter. It is enough to withstand the negative moment that was calculated. Since the negative moment located at the mid span of strip 3, another reinforcement is needed, which the tension reinforcement, the bottom reinforcement will be the same size with the same spacing, and the arrangement can be seen in the figure 1 here.